Transforming linear functions. So we're going to look at vertical transformations and horizontal transformations today. So the thing to know about vertical transformations is that it affects y. So if I give you an equation like f of x equals 3x plus 5, remember that's y equals 3x plus 5, and what's being affected is the 3x plus 5 because that is y. So if I say multiply it by 2, I put a 2 out front. That's a stretch because it's more than 1, and it would be 6x plus 10. If I said do a compression and my factor was a half, I would multiply the 3x plus 5 times a half and distribute, and it would be 3 halves x plus 5 halves. Now keep in mind, a shift is when you add or subtract. So if I say a shift plus 2, that's y is being affected. All I do is I add 2 to it. It'd be 3x plus 7. If it's a subtraction and I'm going down, then I would subtract, like subtracting 2, 3x plus 5 minus 2. So keep in mind again, a compression is when your factor, you're multiplying for compression and stretch. A compression is when your factor is less than 1, and a stretch is when your factor is more than 1. Now the same holds true for horizontal transformations. The difference is a horizontal transformation, it's the inverse. What you see happening to the points and what you see happening in the equation for horizontal only is the inverse. Now keep in mind with horizontal, you can tell it because x is being replaced. X is being replaced with x plus 3 or x minus 3. Or if it's a stretch or compression, with 1 over b times x. Why 1 over b? Because it's the inverse. So if I said it was a horizontal stretch by 2, then it's 1 over b, and you're replacing it with 1 over 2x, or 1/2 x. Now keep in mind, generally, a horizontal stretch is a vertical compression, and a horizontal compression is a vertical stretch. Now that's not perfect in all situations, but for linear it is. So what do I do when it's horizontal? I replace x. That's how I tell. If x is being replaced, it's horizontal. What do I got to know? It's the inverse. Let's look at some examples. Of the two, vertical is easier to understand. Again, vertical affects y. And this whole thing, in this case, 1/3 x plus 2, that's what y is, 1/3 x plus 2. So if I vertically shift up my equation, which I can say y, or maybe I'll call it g of x or something else, but I'll just keep with y here. My new equation would be y equals 1/3 x plus 2, and it's because I'm going up 3, and y is being affected. This is my y. Remember, this was my y. It's plus 2 plus 3. So my equation becomes y equals 1/3 x plus 5. A vertical shift down 5, well, my new equation becomes y equals 1/3 x plus 2 and minus 5, because this was my y, and 1/3 x plus 2 was what y was, and I'm moving every y value down 5. So my new equation is y equals 1/3 x minus 3. A vertical stretch by 3/2. It's vertical. Y is what's being affected. So there's my y, my new y, and everything, that's the 1/3 x plus 2, is going to be multiplied by 3/2. So it's 3/2 times 1/3 x plus 2. Keep in mind that 2 is 2 over 1, and I just multiply straight across. So it's 3/6, which is, of course, 1/2. Let's erase that. So that would be 1/2 x plus, and 3/2 times 2 would be 6 over 2, which would simplify to 3. A vertical compression, again, it's vertical, so y is being affected. So my new y is going to be multiplied by 2/3. I know it's a compression because 2/3 is less than 1. 2/3 times 1/3 x plus 2. So my new equation would be 2/9 x plus 4/3. Horizontal shifts and compressions and stretches. Horizontal is when I'm multiplying for a stretch or a compression. My b factor, notice it's 1 over b times x that I replaced with, and the b is below because it's the inverse. Now, you have to keep in mind, if it's a fraction, and I say 1 over 4/3, that's 1 divided by 4/3, which is really 1 times the reciprocal 3/4. In other words, that 4/3 gets flipped because when you divide by 4/3, you multiply by the reciprocal and you flip the fraction. So what I'd actually be multiplying by is 3/4. So the horizontal is a little harder to understand because you have to remember you're replacing x because it's horizontal, and you have to remember only horizontal is the inverse. What you would see happening to the points and what you see happening in the equation is the inverse of each other. So in this example, my equation becomes y equal 1/3, and I'm going to replace x because it's horizontal. 3 to the left. Now think of the x-axis. 3 to the left, normally you would think -3, but it's the inverse. So x gets replaced with x plus 3 plus 2. And this simplifies to y equal 1/3 x plus 1/3 times 3 is 1 plus 2, which becomes y equal 1/3 x plus 3. Now you may have ugly fractions here, in which case you may want to use a calculator. A horizontal shift to right. So my new equation becomes y equals, and again, to right, think of the x-axis. You normally think it's going to be plus 2, but it's the inverse. So I'm going to replace x, because it's horizontal, with x minus 2, the inverse. So x minus 2. And plus 2 is the rest of the equation. Remember, I'm using this equation right here. All I'm doing is replacing x, which is that, with either x plus or x minus. I'm using the inverse. So this is y equal 1/3 x minus 2/3 plus 2. And go to your calculator and punch in -2/3. I would use Desmos. Desmos is great. And we get 4/3. So y equal 1/3 x plus 4/3. Moving below, horizontal compression. Again, it's 1 over b, so 1 over 1/3. Notice that it's a compression because your factor is, again, just like with vertical. If it's less than 1, it's a compression. If it's more than 1, like 4/3, it's a stretch. But I'm always going to replace x with 1 over b times x. So my equation becomes y equals 1/3. Now I'm going to replace x with 1 over 1/3 x plus 2. You can check this out in the book. This section's in the book. Look at your WAMAP assignment. The section's at the title. You can see how the book explains it. It's exactly like this. Remember that you're going to multiply by the reciprocal, so that 1/3 is going to become 3 over 1 like I did over here. So this ends up being y equal 1/3 times 3 over 1 times x plus 2, and that cancels, so it just ends up being y equal x plus 2. Crowded here. Right, the horizontal stretch, it becomes y equals 1/3 x. Now again, I'm going to replace x with 1 over 4/3 x plus 2. And that seems confusing, but just remember that, just like I showed you, that 1 divided by 4/3 becomes 1 times 3/4. all that happens is that bottom fraction flips, and the 4/3 in this example here, the 3 ends up being up top. So in here, because I did 4/3, the 3 ends up being up top, and it's y equal 1/3 times 3/4 x plus 2. Again, it's the inverse. That's why 4/3 became 3/4. And then the 3's cancel, and I get y equals 1/4 x plus 2. Takes some getting used to. So these are examples off your assignment, and this will go very quickly. So this first one becomes y equals, well, let's stick with what they did, which is g of x for y, same thing. G of x equals, and I'm going to go down. So y is what's being affected, that's my y, and this whole thing is my y. So I'm going to go down, so it's negative 4/3 x minus 2, and I'm moving down. It's not the inverse, it's vertical, because I'm going up and down. So down would be minus 18. So my new equation would be g of x equals negative 4/3 x minus 20. Question 2 here. My g of x becomes, and again I'm going down. Oh, I meant to do an up. Up would be plus. So this would be 13/2 x minus 11, and I'm going down, so minus 12. This was my y right there, as was this. And so this becomes g of x. G of x equals 13/2 x minus 23. 6 left. Well, normally we'd think 6 left would be minus, think of the x-axis, but we know because it's left, it's horizontal, and what do we know about horizontal? It's the inverse. Inverse, got to remember, horizontal is the inverse. What happens to the points and what happens in the equation are inverses of each other, only for horizontal. So instead of being x minus to the left, it's going to be x plus, at least in the equation. So it would be x plus 6. So we're going to replace x with x plus 6. So my g of x becomes negative 1/2, and I replace x with x plus 6 plus 9. And then my g of x will equal negative 1/2 x plus, and negative 1/2 times 6 is 6/2. So actually that would be minus 3 plus 9. And that simplifies to g of x equals negative 1/2 x plus 6. Question 5, 3 to the right. Think of the x-axis. That ought to be going plus, but because it's horizontal, it's the inverse. That means it'll be x minus 3, not x plus 3, because it's the inverse. So my new equation will be g of x equals negative 3, and I replace x with x minus 3, minus 14. And that simplifies to, let's go below, g of x equals negative 3x plus 9 minus 14. And that simplifies to negative 3x minus 5. Here we have some vertical stretches and compressions. That means y is going to be affected. This would not be the inverse. So my new equation, my g of x would equal, now remember this was my y, negative 5/6x plus 4. That was my y, and y. Y is being affected. So everything is going to be multiplied by 5/6. This is compression because 5/6 is less than 1. So this becomes g of x equals negative 25/36x plus, and 5/6 times 4, 4 is over 1, multiply straight across, it would be 20/6, which does simplify. This is negative 25/36. Those don't have any common factors. 25 is 5 times 5. but 20 over 6 would reduce to 10 over 3. Question 10, a vertical stretch, so y is being affected. So my g of x would be 10/11 x plus 6, except for, and that's my y, and so every y is going to be multiplied by 5/3. A stretch and a compression or multiplication. So this is g of x equals, now that would be 50 over 33, which I don't think simplifies. And then that would be 5 times 6 would be 30 over 3. That does simplify. So g of x equals 25 over 33x plus 10. Some horizontal stretches and compressions. Now this is horizontal, so we know it's the inverse. When it's a stretch and a compression, it's multiplication, but I'm going to replace x with 1 over b times x. 1 over b because it's the inverse. So, question 8, my g of x would equal 1/9. Now, I'm replacing x because it's horizontal with 1 over b, which is 1 over 3/2. Make that bar a little longer. X minus 3. Notice only x is being affected. Now, I'm multiplying, so actually I'm dividing here, so I'm going to multiply by the reciprocal. So this would be g of x equals 1/9, and that becomes times 2/3 x minus 3. So my final answer would be g of x equals 2/27 x minus 3. Notice that only x changed. On question 12, my g of x becomes 9/11, and I'm going to replace x because it's horizontal with the inverse, which is 1 over 1/2. And this is a compression because my factor is less than 1, plus 6, and this will simplify, and I'm dividing 1 divided by 1/2, so I'm going to multiply by the reciprocal. This is 9/11, and that's 2 over 1 times x plus 6. So that would simplify to 18 over 11x plus 6. Question 13, last one here. This would become g of x equals, and I'm going to do a horizontal stretch by a factor of 3. Remember, I replace x with 1 over b times x. Now, it's not a fraction. My b is just 3. So this is actually a little easier. And I don't need to, because it's not a fraction, I don't need to multiply by the reciprocal, so I don't need to flip it. It already got flipped, right? Because it was 1 over b times x. So this becomes g of x equals 11/3 x minus 12. These last two examples are reflections. And with a reflection, you always have to think about what's happening to the points. Now, this isn't the inverse thing going on. That's only horizontal. When I do these, I always think of the coordinate plane. And I think of a point, xy. So if I am going to reflect over the y-axis, I'm going to go this way, which means my point becomes negative x comma y. So it's right over here, and only the x changes. X becomes the opposite. So that's what you do. X becomes the opposite. So this equation becomes g of x equals 6/7, and x becomes the opposite. Now, hopefully you're going to simplify that and write that as y equal negative 6/7 x plus 2. Notice, again, this was horizontal, and notice that only x was affected. This last one is a reflection over the x-axis. And just like the previous question, Think about what happens to a point xy. So here's my y-axis and x-axis, and let's take a point xy. When I reflect over the x-axis, I'm going this direction, and my point becomes x negative y. Notice that y becomes the opposite. This is a vertical transformation. So y becomes the opposite, and this whole thing is my y. So my g of x, which was negative 2/7 x plus 9, that's my y and that's my y, and my y becomes the opposite. Notice the parentheses, because y is more than one thing. So I have to distribute, and my equation becomes g of x equals, in this case, positive 2/7 x and minus 9.